Okay, Wildcats, so we're in Activity 3.2, Solving Systems with Matrices. Matrices can be used to solve a system of equations. A system can be written as a matrix equation or equation with matrices. Consider a system of three linear equations in three variables written in standard form: ax plus by plus cz equals d. The system can be written as a matrix equation a times x equals b by writing it as the product of a coefficient matrix and a variable matrix equation to a constant matrix. A coefficient matrix is a square matrix that consists of each coefficient of each equation in the system of equations. In order, when they are written in standard form, a variable matrix is a matrix in one column that represents all of the variables in the system of equations. A constant matrix is a matrix of one column that represents each of the constants in the system of equations. In a system with n equations, the coefficient matrix will be an n by n matrix. The variable matrix will be an n by 1 matrix, and the constant matrix will be an n by 1 matrix. All right, worked example. Solve the system of three linear equations in three variables using Desmos. Okay, so let's go ahead and do that. Okay, but first we need to write this as a matrix. So we have an x column, y column, and z column. So that's 2, 3, -2, -1, 1, -1. Now we have a z column, so that's -2, -2, 1, and then our last column is 3, 11, -8. All right, let's go ahead and plug that into Desmos. So we'll go to Desmos, matrix calculator, new matrix. I need to add a row and then add two columns. All right, so 2, -1, -2, 3, 3, 1, -2, 11, -2, -1, 1, -8. And so then we have our REF of matrix A. And your solutions are x equals 2, y equals 3, and z equals -1. All right, go ahead and finish that up. All right, let's take a look at the next page. Go ahead and mark out 1A, B, and C. Let's take a look at 2. Write each system of equations as a matrix equation. Okay. So we have an x column, y column, z column, and our constants. So then that's 1, 2, -1, 2, -1, 3, -2, 1, 2, and then -8, -1, 13. All right, let's go and take a look at B. All right, now the issue is the y here is on the wrong side, so we need to move it to the other side. Okay, so we have, let's come over here and work with it. Okay, so we're going to add 4y to both sides. And so we have 5x plus 4y. Now, it should go x, y, z. We don't have a z, so I'm going to put plus 0z equals, and then this becomes 0, so equals 0. So we're going to rewrite this as 5x plus 4y plus 0z equals 0. Now, write that so it's easier to see. Okay. Now we have our x column, our y column, our z column, and our constant column. So now our matrix is 3, 5, -1, 2, 4, 2, 2, 0, negative 1, 4, 0, 12. All right, go ahead and finish it up. All right, go ahead and mark out number 3. Let's take a look at the next page. Remember to use technology with matrices as a tool in solving matrix equations. Okay, solve the system equations using Desmos. So we need to convert this to a matrix. We have our x column, y column, z column, and our constant column. So we have 2, 3, negative 2, negative 1, 1, negative 1, negative 2, negative 2, 1, 3, 11, negative 8. All right, let's go ahead and use Desmos. I'm going to delete what I have here, new matrix. New matrix. We're going to add a row and 2 columns, and then so we have 2, negative 1, negative 2, 3, 3, 1, negative 2, 11, negative 2, negative 1, 1, negative 8. And then we're going to do RREF of matrix A. And our solution is x equals 2, y equals 3, z equals negative 1. Okay, go ahead and mark out the rest of that page. Let's take a look at the next page. Recall that when any row of a matrix is a multiple of another row, or any column is a multiple of another column, the inverse of the matrix does not exist. When a coefficient matrix is a non-invertible, the system is not able to be solved. In the case, the system will either have many solutions or no solution. When using technology, you will get a similar error message for both cases, because in both cases, the inverse of the coefficient matrix does not exist. You can use a constant matrix to differentiate between a system with many solutions and a system with no solutions. Okay, let's go ahead and solve the system's equations using Desmos. So, we have our x column, our y column, our z column here. So we need to write that as a matrix. So that's 1, 2, 1, 5, 10, 1, negative 2, negative 4, 3, 3, 6, negative 1. All right, let's go ahead and put that in Desmos. So new matrix. So then that's 1, 5, negative 2, 3, 2, 10, negative 4, 6, 1, 1, 3, negative 1. Enter RREF of matrix A. And then what you see here is the last row is 0, 0, 0. That means that there's infinite solutions. Okay, so when you see this, when you see the last row, all zeros, it means infinite solutions. So let's write that down. So again, if you're ever solving using RREF and you see the bottom row all zeros, it means that it's, and they say many, let's use the correct mathematical terminology, infinite solutions. Okay. All right, let's take a look at the next. So we need to verify we have an x column, y column, z column. So let's convert this to a matrix. So that's 1, 2, 1, 5, 10, 1, negative 2, negative 4, 3, 3, 7, negative 1. Let's go ahead and plug that into Desmos. New matrix, add a row, add 2 columns. So 1, 5, negative 2, 3, 2, 10, negative 4, 7, 1, 1, 3, negative 1. Enter RREF of A. Now, if the bottom row has all zeros and a 1, that means there's no solution. Okay, so if you see this, all zeros and a 1, then we know that it's no solution. So let's write that down. So okay, so there's your example of infinite solution and no solution. All right, go ahead and mark out number 5, and let's take a look at the next page. All right, go ahead and mark out 6A and B. The teacher works A and C, and the student works B and D. Okay, so let's take a look. Now, we need to convert this to a matrix. Go write that down to remind ourselves we need to find x, y, and z. Now, our x's are 2. There's no x, so we're going to go ahead and add a 0x here. So we have 2, 0, 1. We look at our y, so that's negative 3, 1, 2. Now, this doesn't have a z, so let's go ahead and add a plus 0z. Seven. Sorry, I accidentally erased the 7. Okay. So now we have 0, 1, 4. So 0, 1, 4. And then we have 7, negative 5, negative 17. All right. Let's go ahead and plug that into Desmos. So 2, negative 3, 0, 7, 0, 1, 1, negative 5, 1, 2, 4, negative 17. Enter RREF of A. And so our solutions are x equals 5, y equals 1, and z equals negative 6. All right, let's take a look at C. So we have an x column, y column, z column, so we're good. So then that's 1, 2, 4, negative 4, 3, 1, 3, negative 5, negative 1, negative 7, 19, 17. And we're looking for x, y, and z. Let's go ahead and plug that into Desmos. New matrix. So 1, negative 4, 3, negative 7, 2, 3, negative 5, 19, 4, 1, negative 1, 17. Then RREF of A. And so our solutions are x equals 3.5, y equals 1.5, and z equals negative 1.5. Alright, go ahead and complete B and D on your own. And then let's take a look at the next page. Talk to talk. Show us your stuff. As you learned in a previous lesson, you can model a real-world situation using a system of linear equations. Now you should have another tool to use to help you solve the system. The teacher works 1A and the student works 1B and 1C. Okay. Number 1, your school key club decided to sell fruit baskets to raise money for a local charity. The club sold a total of 80 fruit baskets. There were 3 different types of fruit baskets. Small baskets, so let's call X equal the number of small baskets. There are 3 different types of baskets. Small fruit baskets sold for $15.75. Medium baskets, so let's call Y number of medium baskets. And then for $25 each. And a large fruit basket sold for $32.50. So we have here Z is the number of large baskets. The Key Club took a total of $2,886.25. They sold twice as many large baskets as small baskets. Okay, so let's write our 3 equations, okay? Now, our first equation, let's do total, okay? So our first equation is X plus Y plus Z equals 80. Now, the second equation is all about money, okay? So it's right here. So that's 1575x plus 25y plus 3250z equals money, 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 money. And then last equation, they sold twice as many large baskets as small baskets. That means that 2x plus, 2x equals z. All right, go ahead and write that down, and then go ahead and finish 1B and 1C on your own. All right, let's take a look at the next page. Go ahead and mark out the right part, and you can read the remember if you want. The student works 1C and 3A. All right, let's take a look at the next page. the student works 1, 2, and 3. And it's really simple. All you need to use is Desmos. And you'll put this matrix in, put a multiply, this matrix, and so on. You'll do the same thing for each of those. Real simple. All right, go ahead and finish up your assignment and have a wonderful Wildcat day.